Okay, so when we are using Trig, when we are using SOHCAHTOA to solve for missing values, we're going to use our calculator. And the key is to keeping your calculator in degree mode. So there's two modes for your calculator. In geometry, we're only using degree mode. To make sure that your calculator is in the right mode, you press the mode button, and then this screen will appear, and you'll use these arrows to tab down to the third line, and then there's going to be this blinking black box, and you want to hover it over the word degree. So you use the arrows, then you're going to press enter and make sure that that black box is over the word degree. So press the mode button, use the arrows, make sure the black box is over the word degree. So we're going to clear our calculator every time we take a test or a quiz. So when you clear your calculator, it resets to radian mode, so you always want to make sure that you change it to degree mode. So if you're working these problems and you start getting some really funky answers, first thing you should do is just check and make sure that your calculator is in degree mode. Okay, here is an example of how we are going to use SOHCAHTOA, how we're going to use Trig to find missing sides. So we have this random right triangle. It's not a special right triangle. It's not a 30, 60, 90. It's not 45, 45, 90. So we can't use special right triangles. We only have one of the side lengths. So I can't even do Pythagorean theorem because I need two side lengths to do Pythag. So I'm stuck. So I have one angle that's not the right angle and one side. That's all I need to find all the other missing angles and sides in a triangle, which is pretty cool. So I want to find the length of QP. So I'm going to call QP X. And I have this angle P, 60. So P is my theta. So I'm going to label the sides of this triangle based off of this angle P being my theta. So if 63 degrees is my angle, then QR is the opposite side. QP is the adjacent side, and 12.9 RP is the hypotenuse. So I'm going to write SOHCAHTOA at the top. And what I want to do is I want to think, I have one side length that's given, and I have one side length that I'm trying to solve for. So I am given the hypotenuse, and I'm trying to solve for the adjacent side. Adjacent and hypotenuse. So A and H, this opposite side is irrelevant. I don't know its length and I'm not trying to find it, so it doesn't matter. But I'm looking for the adjacent side and I'm given the hypotenuse. So I want to go to SOHCAHTOA and think, okay, which of those three trig functions, sine, cosine, or tangent, which of those three trig functions relates the adjacent side and the hypotenuse? So cosine relates the adjacent side to the hypotenuse. Cosine is the ratio of the adjacent side over the hypotenuse. Cosine of theta is equal to the adjacent side over the hypotenuse. The length of the adjacent side over the length of the hypotenuse. So now I can just go plug in my values in the equation. So cosine of theta, I'm going to put the angle, which is 63 degrees, in for theta. And now I am going to go plug X in for my adjacent side. I don't know my adjacent side. My hypotenuse is 12.9. So I'm going to go plug 12.9 in for the hypotenuse. So I have just set up my equation. So I want to solve for X. So I got to get rid of this 12.9 that's in the denominator. So I'm going to multiply both sides by 12.9. And they cancel out over here. And so now I'm just going to go type 12.9 cosine 63. So if you go back to your calculator, if you look right up here, sine, cosine, and tangent, these are your trig buttons. So you're just going to press the trig button and then the angle and press enter. So I'm just going to go type 12.9 times cosine of 63 in my calculator. I get 5.856, blah, 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 blah. And so I'm just going to round to the nearest tenth, which is 5.9. So QP rounded to the nearest tenth is 5.9 centimeters.